What is going on, everyone? Welcome back. This is the Turfgrass Pest Management Chapter 7, Diseases and Disorders of Turfgrass presentation. Just so we all know, we're following along the Michigan Pesticide Applicator Category 3A Turfgrass and Pest Management book. If you're in a different state, I will say that this has a lot of useful information as far as turfgrass in general. So it can be useful to you. But if you're in Michigan, we're following exactly this book. I'm pulling out all of the important information that we need to know so you can pass your Category 3A exam. So yeah, sorry about the delay. I usually, post these videos on Tuesdays and Thursdays. Today's the Thursday. I'm recording this in real time. It is the 28th. And I've been busy. Been very, very busy. And actually, I'm going to show you guys what I've been doing. Okay. So this is a new client of mine for mosquito control. And this is on a 110-acre property. And each one of those colors, if we look at the red, yellow, and the white, those are all mile-long stretches of trails. And so I've been busy dealing with this, which is why there's been a little bit of a delay here in the content for you guys. But yeah, this is an awesome project. It's the first project I've ever needed a handheld GPS to go market. And so it's a very unique one. Overall, this is probably going to take 350 gallons to complete. It's going to take 3.5 tanks with a 110-gallon sprayer, basically. And yeah, this has been taking up a lot of my time. So I wanted to let you guys know why there's been a delay and what I've been doing in the background. I am a pesticide applicator. I do have a pesticide applicator business. And so, this stuff here is kind of like a side project of mine, and I'm just doing it as I can. I'm going to get Chapter 8 out to you guys next week, hopefully. Tomorrow, which would be Friday real time, I'm going to be having a surgery, and so I'm going to be a little bit delayed on recovery from that. But overall, we're all good. This chapter is pretty in-depth. We got a lot to cover here. There's a lot of different diseases, how to manage them, disease triangles, things like that. So without further ado, let's dive in. Also, just so you know, sometimes I use certain slides, certain templates, and they don't always jive very well with the software that we're using to record these. So I hope it looks okay. I went through it, and some of the slides are like, what the heck happened? It brought pictures ahead of certain things, but doesn't look like any of the content was too covered, and I tried to make adjustments as I could. So without further ado, let's dive in. In case you don't know who I am, I'm Austin Douglas with Elevate Applicate, and here we're all about helping pesticide applicators get into this industry, making their exams a little bit easier. So let's dive in. All right, so the objectives of this chapter, Chapter 7 in the 3A manual. Describe the difference between turf diseases and disorders. Name components of turf disease pyramid and understand how they help manage disease problems in turf. List the methods for managing the host, managing the environment, and managing the pathogen. We also want to note prevention and control. These are two different options and two different things that we need to deal with. We want to analyze a situation to identify if it's disease or stress. We want to describe stand symptoms in turfgrass. And we also want to describe plant symptoms in turfgrass. Again, if you guys are, not in Michigan, maybe you're down south, this is probably going to be pretty different for you. Down south, you guys have different grass types, different diseases that you got to deal with, things like that. We also want to be able to list the common signs of a fungal infection in turf, describe turf symptoms that would indicate nematodes, which I'll just, foreshadow that. Nematodes are quite rare in Michigan. So we shouldn't have to worry about that too much. And then explain the difference between a protectant or a contact fungicide and a systemic fungicide. If you guys have been watching, my core series at all, or if you've been watching any of this, contact and systemic. Contact is basically going to kill on contact. A systemic is going to be absorbed into the plant material and work more long-term. So just, a quick overview of contact and systemic. I trust that you know what that is. If not, we're definitely going to dive into it more. Okay, so intro, diseases and disorders. Sometimes diseases are the most difficult things to control in turf. The reason for that is because they're difficult to identify. If you can't properly identify what's going on in the turf, how could you possibly prescribe and administer the correct treatment program, right? So we have to be able to identify it. Disorders are caused by unfavorable growing conditions. You have to think temperature, soil compaction, overuse of chemicals, water management, fertilizer, light. There's a lot of different things that can cause plants to be stunted or grow poorly, and we have to keep all of that in mind. Diseases are caused by pathogens, right? So that's a main difference right here. Disorders are mainly environmental and things that are relatively out of our control in some instances. Diseases, though, are living organisms, whether they're fungi, bacteria, viruses, and nematodes, which nematodes are classified into a pathogenic organism, but very, very few nematodes actually harm plants. So always good to know. So here we have disease development. Now I want you to take a visualization of this picture on the right. Okay, this is called the disease triangle or the disease pyramid. It all basically depends on if you have a 3D model or a 2D model. But we have a susceptible host at the top, we have a pathogen on the left, and we have favorable environment on the right. And you'll notice that they put this diagram where all these circles have to overlap. And when all three of them overlap, that's when we get disease. And that's because we need all three of these things to be at the perfect storm in order for a disease to take place, right? You could have a pathogen and a favorable environment, but if you don't have a susceptible host, it's not going to get a disease. You could have the pathogen and a susceptible host, but if the environment's not right, it's not going to be infected. You could have a susceptible host and a favorable environment, but if the pathogen's nowhere near to be found, it's not going to be infected, right? So I do want to, you really need to learn the triangle and understand that, because a lot of management in diseases, trees, turf, you name it, is altering one of these things to kick it out of that central point so it doesn't get an infection, so it doesn't catch these diseases. Now, there's some diseases that, I don't know. This is pretty much, this is the golden rule. I should say that. Okay, so let's dive into this a little bit more. Not every plant exposed to disease inoculum becomes infected. So you could have the pathogen, you could have the susceptible host, but not the favorable environment, and it's not going to get the disease. You need the development of the infectious disease, the development of the infectious disease requires all three of these things, right? We kind of covered that pretty in depth. But then there's a fourth aspect of it. And if you wanted to envision this like a pyramid, you would envision time as another factor. That would be the vertical factor. And why that is because the longer time frame that a pathogen exists and a susceptible host exists, in the longer time frame, the environment can become favorable or vice versa, right? If you have a susceptible host and a favorable environment, the longer the time is that those exist, is more likely that a pathogen could then take hold and cause disease. And so you have to think of it in all these ways, right? But time is another factor that is not displayed on this particular photo, but it is a factor. Okay, so disease development. If one of these factors is missing, the disease will not occur, right? When managing diseases, you want to look for ways to eliminate one or more factors of the disease pyramid. You either want to change the host, which is pretty difficult in turf grass, unless you're doing a total renovation. Change the environment. That's pretty easy. Not easy, but it can be doable, right? Maybe you insert some drainage. Maybe you do some aerations. Maybe you limb some trees up and get more sunlight down there. Or, lastly, apply a pesticide to kill a pathogen. The thing about pesticides is that they're likely a short-term solution as far as disease problems go. So we have to view it that way. If you can alter the environment, you're doing much, much better at fixing an issue long-term than just applying pesticides. And we'll see that once we dive into various specific diseases in this presentation, that a lot of things, they actually don't even recommend to apply fungicides. They recommend to alter the environment or alter certain things because long-term it's going to be better for the turf. So there's three strategies to protect turf from disease injury. We can manage the host, we can manage the environment, and we can manage the pathogen. Okay. Managing the host is probably the easiest because you can, manage the turf. You can do what the turf wants, make it vigorous, have it grow super healthy, and it probably won't be susceptible. Managing the environment is probably second as far as the easiest goes. You can do drainage, aeration, put a variety of seeds if you do an overseeding. And then we have managing the pathogen. This is going to be our chemical makeup, possibly some cultural practices to manage the pathogen. But you can't eliminate pathogens from the environment. It's just not going to happen. So we have to be aware that they are there, but we want to eliminate the susceptibility and increase how good the environment is for turf to grow. Okay. So let's talk about managing the host. Diseases are most favorable for pathogen development when conditions are favorable while turf grass is unfavorable. While the conditions are unfavorable for turf grass, I guess is how I should have written that. If turf that is healthy and growing vigorously resists disease, and it just makes sense. It's the same concept in tree work. If a tree is healthy, if a plant is healthy in general, it's less likely to be susceptible to any sort of disease or insects for that matter. And that's because it has a healthy immune system that it can fight things off. If you think of, you see people that work out consistently, they're very, very in shape. They're less likely to be sick than somebody who's, 500 pounds obese. That person's way more likely to be sick because their environment and their body is not in a healthy state. Experienced turfgrass managers promote healthy turf capable of resisting, tolerating, or outgrowing infections, disease, and damage. So, even on golf courses, their main thing before they introduce fungicides or anything like that is to promote healthy growth of turf. Okay, so let's talk about managing the host. Host-related factors to consider if turf grass is suffering from disease. What is the cultivar, right? What kind of grass are you growing? You want to make sure that cultivar is well adapted for the site and use. If not, you definitely need to think about replacing it with disease-resistant cultivars. You also want to think about the mixture of grass seed that you're throwing down. Is it cool season, warm season? Is it compatible cultivars? Do you have a nice mixture? You want diversity in your turf so that way diseases can't really take hold too well. You also want to think about the soil. You want to think about the fertilizer and the pH. You want to administer soil tests. You want to find out the nutrient levels. What are the pH levels? Because if your turf is being stressed out because it's got poor soil, well, now you have to improve the soil. If your turf's being stressed out because it can't access nutrients because the pH level's off, well, now you know that you need to administer some sort of treatment application to adjust the pH to increase the health of that turf. You also want to think about sharp mower blades. Why? Because if you have dull mower blades that are cutting frayed grass blades, what's going to happen is it's not a nice clean cut. And so diseases can very easily get into that grass. It's no different than trees. If you have a poor cut on a tree when pruning, it's not going to heal as well. And so it's going to make it more susceptible to decay and disease, etc. You also want to think about the mowing height, right? There's a rule. It's the 1/3 rule. You only want to take off 1/3 of the length of the grass blades. If you're cutting more than that, you're stressing the grass out. If you're cutting less than that, well, then it's just going to grow out of control. So we want to keep it at that 1/3 rule as best as we possibly can. And then lastly, you want to think about moisture levels, which moisture is probably one of the most important things when talking about turf. You don't want too much and you don't want too little. So let's talk about managing the environment. There are times when the environment can be altered to reduce turf susceptibility to disease. The number one management strategy to manage the environment is in irrigation. Irrigation is by far the most critical factor in disease and insect damage prevention. It also can help turf recover. And it makes sense, right? If you have a drought-stricken turf stand and you start to irrigate it, or if you know that you have hot weather, you can cool it down, right? These are all things that irrigation does. But if we have too much irrigation, what's going to happen? It's going to restrict the oxygen within the root system. It's going to cause roots to die. It's going to cause, plants to die off. Water on the leaves could cause a fungal infection because it's creating the right environment. But too little of water and irrigation is going to stress the turf out and also increase the susceptibility. So we really have to balance on how much we're watering. We have to understand the environment. I see places all the time that, we get a week's worth of rain and they still have irrigation running during the day, every day for a week. And they really didn't need that. They could have shut that off. So we have to understand management as a whole encompassing process, not just as pesticides. So let's continue talking about managing the environment. There's airflow, right? How can we increase the airflow to the turf? If we have airflow, then we're not going to have moisture and humidity sitting on these leaves, creating the perfect environment for pathogens. So we could maybe reduce thatch. We could trim some underbrush, some lower branches on trees. You could actually completely remove trees if you needed to. But these are all things that we can do that are relatively cultural practice, no pesticides at all. It just depends on how much the client's willing to do to have a healthy turf stand. There's also drainage, right? Grass grows best in well-drained, aerated soils. And establishing a turf stand, it's pretty much essential that you want to enhance that subsurface and surface drainage. You want to have the right amount of moisture ready for those plants when they want it. Soil compaction is another thing in the environment that we can fix. It restricts the growth of roots. If the ground is too compacted, those roots basically can't penetrate that soil, and so they just sit there in suspended animation, keeping whatever above ground alive. It reduces water in the soil. So if you have overly compacted soil, it's really, really hard for that soil to percolate down into the ground, into the root systems. And then conversely, if you that's limiting the water, but what happens when it's completely saturated? Well, that's going to limit the oxygen and the roots die, and then in turn the plants die. So these are all main factors that we need to be aware of when we're thinking about managing turf stands. We also have thatch. Thatch layers can create ideal environments for disease organisms. The reason for that is because it's decaying matter, and a lot of fungal pathogens feed off of decaying matter. And so your ideal thatch thickness is going to be 1/2 inch. And if you have more than that, then you might want to be thinking about dethatching or aerating a lawn pretty regularly. Once a year, twice a year, dethatch, aerate, and overseed. And then you'll slowly get a super healthy turf stand just from that alone. We also have weather conditions, which these are pretty much out of our control, but we have to understand them. Diseases developed in turf depend greatly on weather conditions. From rainfall to dew to soil temperatures to soil moisture, all of those factors that are out of our control, they're going to cause some significant issues with turf. We also have microclimates to deal with. These are areas that are small and the growing conditions are different than the areas around it. And I see microclimates all the time in forests and properties in neighborhoods because it is different. Somebody might have more canopy cover. Somebody might have less canopy cover. Somebody might be in a valley, somebody might be on top of a hill, and everything changes based on all of these things. Small differences in the growing conditions can have a major effect on disease establishment. And why is that? Well, again, if we go back to that disease triangle, you're going to think, the environment, right? You have to have a susceptible host, you have to have a pathogen, and you have to have a favorable environment and time. So if in one area, you might not have all three of those in combination, but in a microclimate, you might have that. And so then it takes hold. So let's talk about managing the pathogen. All right, so managing the pathogen. Fungicides are the main tool for managing pathogens, but they are short-term, and we need to remember that. They are not long-term solutions, even though majority of the lawn care companies out there that do residential work seem to apply them annually. They should really only be applied when necessary. Fungicides are rarely needed in home lawns, which, like I said, most companies do it anyway, just as part of their program, as a preventative. But the reason why they're not really needed in home lawns is because you need to have good cultural practices. If you don't have good cultural practices, then it's not going to be ideal. You're going to probably have, issues in the lawn if you're not having good cultural practices, which just makes sense. Pesticides should not be the sole management method for dealing with turf diseases. because we want those good cultural practices, right? Preventative fungicide treatments are often more effective than curative treatments, which again, if we go back to, my understanding of the industry, most companies that deal with residential lawn care, fertilization, weed control programs, they do run a fungicide application as a preventative. It's just part of their regiment. Again, it's just, they're trying to prevent any sort of issue from happening. And they're probably only applying it when, that disease triangle is going to be closest to the center. You're not going to apply it during certain times of the year when you know that you're not really going to need it. So what are protectant fungicides? Protectant fungicides are contact fungicides. These coat the plants with a barrier against fungal infections. That barrier is going to prevent spores from germinating on the leaf blades. They're not absorbed into the plant. Thorough coverage is absolutely necessary, because if you don't have thorough coverage, then you have areas that are exposed because they don't have that coating, and then the fungus can still occur. They're generally broad spectrum, and they're not very prone to resistance issues because of that. They do not protect new growth, though. They're washed away. It goes away when you mow and you cut those blades down. It degrades from sunlight and microbes. And this is pretty wild. Reapplications may be necessary every 5 to 10 days, which makes sense. You think of how often people are mowing their lawns. We mow our lawns once a week. Sometimes, if it's a really good growing season, you might have to mow it every 5 days. So this is not ideal for residential properties for this reason in particular. There's no way, if you have a long client list, that you're going to be able to go to every property every 5 days. And I don't think the clients are going to want to pay for that either. Then we have systemic fungicides. Systemic fungicides circulate within the plant. They can control disease already within plant tissues. They do provide a much longer residual control. They're not washed away or degraded by sunlight. They protect the roots, the crowns, and newly formed tissues. And there is a possibility of creating a resistance. And so because of that, we need to rotate our products with different modes of action to reduce fungicide resistance. If you were doing commercial lawn care applications to residential properties, even commercial properties, I would highly recommend that you're going to use systemics over contacts. Specifically for this reason, you're not going to be able to go to all those properties every 5 days, whereas systemic's going to buy you time. Okay, so signs and symptoms. When identifying plant injury, you must determine if the cause is disease, if it's a cultural issue, or if it's environmental. Okay, that's critical. And sometimes that can be very difficult to identify. If it's been determined that it's a disease, you need to find out what specific disease you're dealing with. This is going to help you determine your management options. If you don't know what specific disease you have, how could you possibly create a management plan? And then also, it's worth noting that certain pathogens favor certain grass types. That's worth noting because if you're looking at a certain grass type and you think it's this pathogen, but that's not a susceptible grass type, then it's not. So you can eliminate it from your list. Oh. So we need to read the stand and we need to read the plants. Stand symptoms are evident from a distance. You see rings, spots, circles, patches. Plant systems are evident on individual plants or plant parts. This is when you're looking a little bit closer to the plants, down in the turf. You're looking for spores, for lesions, blight, dieback, crown, and root rot. Also, each turfgrass disease produces specific stand and plant symptoms. So you want to carefully examine the symptoms. Fungal pathogens produce specific structures. You're looking for visible lesions, spores. You're looking for mushrooms in the area, for mycelial growth, for white powdery mildew, red and black pustules. You're looking for these things because that'll indicate that it's a fungus. It's a fungal pathogen that's causing the issue. When symptoms, visible signs, or environmental conditions do not allow for a diagnosis, you should seek help from labs for a diagnosis. Here in Michigan, it's highly recommended to use MSU Extension Office. If they're too busy or if they're not taking on new work, there's always Purdue. There's a lot of places, independent labs. You just got to Google them and they'll pop up. So let's talk about turfgrass disease diagnosis. For successful disease management, you must first diagnose the injury or damage, and you have to make sure that it's been caused by an infectious disease. It's nearly impossible to determine the species of the disease-causing organism, especially if you don't submit it to a lab. So you want to be able to submit it to a lab so you know exactly what you're dealing with, exactly how to manage it. So let's talk about fungi. These are microscopic organisms that feed on decaying organic matter. They're going to be feeding on roots, leaves, animals. Few attack living plants, but the caveat there is that a lot of fungi attack trees. There's actually a war between fungi and trees constantly. There's parasitic fungi, which enter through the outer layers, the outer cuticles, and also through fresh wounds. And then they start to eat away at the plant and germinate and sporulate. The spores germinate on a host and transfer through wind, splashing, animals, equipment. Also, fungi prefers moist conditions with limited air movement. So if you know that you're dealing with a fungal disease, what you want to do environmentally is reduce the moisture conditions if you can. Here in Michigan, it's kind of difficult. It gets pretty dang humid. And then you also want to increase the air movement. Maybe you want to trim some brush. Maybe you want to limb up some trees. So that way more air, more sunlight gets down to this area. And fungi can also overwinter in thatch, which is good to know. So it might be wise to do some dethatchings. So let's talk about some common diseases. Okay, this is anthracnose. It prefers annual bluegrass. The patches are between 2 inches to 10 feet wide. There's a yellow, bronze, or reddish brown color that it changes the grass into. It rapidly grows during prolonged hot, humid weather. Think 80s and humid. It can be seen with a hand lens. You'll see these black, spiny, cushiony spores, which is why I have this zoomed in picture right here. That'll definitely, indicate that you're dealing with some sort of anthracnose. Most severe in annual bluegrass under stress, and some underlying conditions that can be causing this might be compaction, drainage, or a lack of nitrogen. This is dollar spot. It's a serious disease in creeping bentgrass, annual bluegrass, perennial ryegrass. It's easily recognized by the small bleached out spots, the size of a quarter or a silver dollar, hence the name dollar spot. It's going to be most visible on low-cut lawns because the areas appear sunken. So if you're on a golf course, you're more likely to spot this than in just a lawn that's measured at, cut at 4 inches. Just because it's more visible. It's light tan lesions with dark brown, reddish brown borders that girdle leaves. So when you get down to the leaf, you'll see these little borders. You'll see a little girdling a ring around the leaf. And it mainly girdles Kentucky bluegrass and creeping bentgrass. It has a white, fluffy fungal strands that can be seen early in the morning. Okay, so this is a fairy ring. Fairy rings are fungi that live in the soil and develop in areas that were previously forested or where stumps or other organic matter was used as fill. It's most identifiable in spring and early summer. It produces dark circles or arcs. The grass is very fast growing because this fungus produces a chemical that causes the grass to grow. And we can kind of see in this ring in this picture, right, we have an area that has darker grass, it's faster growing, and then we also see a ring of mushrooms. So in this situation, I would say it's pretty likely that a tree was there, a tree was removed, the stump was ground, and then the organic matter that's under the ground is decaying, and this was allowed to take hold. The dead ring develops outside of the circle a few inches to 50 feet in diameter, so it can be pretty big. It's also more prevalent with rain. Mushrooms are going to appear, and it's not as serious on residential turf. Management for this particular disease is difficult and expensive. If you have infected soil, it must be completely removed and replaced. There's also fumigation where you would inject a gas down into the ground to kill this fungi, but that is hazardous and probably not recommended. Here's leaf spot and melting out disease. It's caused by a variety of fungi. It can develop most of the year. It's most active in Michigan during cool, moist weather of spring and fall. You'll see small black, purple-like lesions on the leaf blades. The lesions join together to form large, elongated infections. And drought causes spread of this disease down into the crowns and the roots, which then causes the melting out. The areas turn yellow, brown out, and die, just like we see in this picture. It's mainly an issue in Kentucky bentgrass and finally fescues, but the melting out mainly occurs in Kentucky bluegrass. The main management strategy for this is going to be to reduce stress, which means you want to raise the mowing height, fertilize with 1 pound of nitrogen per 1,000, lightly irrigate daily to try and relieve some stress, increase the air circulation. And then if you have to use a fungicide, you have to make sure that you have the right timing of this. But it's expensive. Okay, so here's pink snow mold. It's caused by a fungus that survives in thatch. It thrives in cool, wet conditions. It's whitish gray to reddish brown as far as how it develops. So if we look at this picture, right, we can see that we got a more whitish gray in the center and then like a reddish ring on the outside. These rounded spots can be anywhere from 2 inches to 2 feet in diameter and develop without snow cover. After the snow melts, pink fungal strands can be seen on the edges of the spots. This is mainly going to affect your annual bluegrass, perennial ryegrass, creeping bentgrass. Those are all varieties that are very highly susceptible. Management of this disease is to avoid early fall nitrogen fertilization. You want to do a preventative fungicide and then repair the injured turf by raking and replacing it. Okay, so this is necrotic ring spot, which, I mean, if you see this in a lawn, that's a nasty looking disease. It's caused by the fungus Ophiospheriella corae. I don't speak Latin, so give me a break. It's a serious issue in Kentucky bluegrass. It's really obvious in midsummer when turf is drought stressed. You'll see wilted, dying, dead turf spots. This can be anywhere from 2 inches to 12 inches wide. It causes streaks, crescents, or circles in the turf, as we can see here. It favors warm, wet periods followed by drought. So we have, an environment that's hot and humid, perfect environment for fungus. And then we have stress associated with that. It's also associated with hot turf and compaction. So if we can alleviate the compaction, cool down the turf, this is less likely to develop. The management for this is to plant resistant Kentucky bluegrass varieties, avoid stress on the lawn. Infected lawn should be lightly irrigated daily and probably at the hottest points in the day just to cool it down. Fungicides are useful at the first signs of symptoms. So always good to keep that in mind. Here's nematode damage, which is, again, I told you this earlier, very unusual in Michigan. You definitely want to investigate the possibility of roots are poor, zero response to fungicides, or bacterial diseases eliminated. This is going to cause thin turf. It's going to lack vigor. It's going to be pale yellow. It doesn't respond to water or fertilizer. If you examine the root systems, you'll see swollen galls. And just remember, only a few species of nematodes actually feed on turf. So this is a super rare thing. You definitely want to get this, lab tested to make sure that this is what you're dealing with, which again, that's part of the management, right? You need a professional diagnosis to confirm it. Limit the nematodes as a pest using quality planting material, frequent light watering midday, which I don't know why they put that in the book because, just above this, it says that it doesn't respond to water or fertilizer. So to me, that doesn't make sense, but okay. Then last resort, we want to apply a nematicide. Here's another common disease. This is powdery mildew, very easily spotted. If you've ever seen powdery mildew on a plant, you just pick a plant up, you'll see a bunch of white powder on it. It wipes off. This is really common in Kentucky bluegrass when nights are damp and cool and the days are cloudy, which is, another good environment, humid, cool, no sun. It's white, it's powdery patches. Often causes yellowing of the leaves. They wither, they die. It can also reduce growth. The management of powdery mildew is going to be to avoid planting Kentucky bluegrass in shady, wet areas. Makes sense. And then also plant shade-tolerant grasses like fine fescues. Another common disease is Pythium blight. This is going to affect your perennial ryegrass, your creeping bentgrass, and your annual bluegrass. It's a hot weather disease. Basically, daytime temps need to be in the 90s and nighttime above 75, which that seldomly occurs in Michigan. Generally, our nighttime temps stay around 70. They produce round, irregular, water-soaked, greasy, sunken patches. These can be up to 12 inches wide. In the mornings with high humidity, thin white mold growth associated with leaf lesions are visible. It quickly fades from a reddish brown to a straw color, and that's just, the plant dying. It appears in elongated streaks following water drainage or mowing patterns. So you can see in this picture, it's following a certain pattern, a streak, probably where water is moving. The management for this is going to be to improve the drainage, avoid overwatering, avoid a thick thatch layer, so dethatchings, decrease compaction to let water soak down into that soil and not rest and sit there. And you don't want to excessively fertilize this. And then lastly, use fungicides as an application. This is a disease called red thread. You can see in this picture, it does have red threads. It's irregular to circle. It's ragged, light tan, pinkish patches, 2 to 12 inches wide. It develops during prolonged humid weather, which in Michigan, we have a lot of humidity. It may merge to form larger bleached tan or yellowish scorched areas. The fungal threads, which are those reddish pinkish color, are generally about 1/4 of an inch long, and they protrude from the leaves. They're initially that coral pink color and gelatinous, and then later they dry out, become brittle, and turn red. The management strategies for this is to maintain turf vigor, use proper fertilization, remove the clippings, which by doing so is going to reduce the inoculum, the spores and the fungi in the turf. This is Rhizoctonia brown patch. This one disease here in Michigan, it attacks all of our turf species. You're going to find this mainly when day temperatures are in the 80s and above, and we have high humidity. It's disguised by actively growing turf. So this one's kind of difficult to spot. Infected turf shows damage quickly during hot, moist, overcast weather. It's often slimy. Patches are up to 2 feet wide. It produces a grayish black smoke ring of wilted, blighted grass, which may be evident on the patch edge, which if we look at this picture, the reason why I chose this is because you can see that smoke ring. You can see the death on the inside of the circle, and you can see that ring that they're talking about. It's pretty easy to identify it when you can see that. The management for this is to avoid high nitrogen, which is going to increase the Rhizoctonia fungus. You want to remove dew in the early morning and increase air circulation. And fungicides for this particular disease are best as a preventative. I was actually reading in the book that certain golf courses will actually use fans on golf putting greens to try and dry out that morning dew early. So pretty unique strategy. Not really going to be doable on residential lawns. This is rust. Rust affect all turf grass types. In Michigan, you're primarily going to see this on Kentucky bluegrass and perennial ryegrass. It prefers warm, hot, dry periods. The turf becomes a reddish brown to orange. And those are the fungal pustules on the grass blades. This causes turf to be more susceptible to other issues, which is pretty interesting. The management strategy for rust would be to plant resistant varieties and maintain vigor. And if you ever walk through grass with rust, you'll notice your shoes are pretty orange. That's a good indication that you have rust. This is slime mold. All right, so let's talk about slime molds. This one in particular is actually called dog vomit slime mold. Pretty characteristic of it, I suppose. These are harmless fungi that feed on decaying organic matter. They live in the soil, the thatch, the surfaces of the foliage. It's a warm weather fungus. It can be white, gray, black, cream colored. These masses grow over grass blades after rain or irrigation. It develops into streaks or patches that smother the turf, and it dries into crusty mats. Management for this is going to be raking it, brushing it, spraying the slime mold with water to get it off of the blades and remove it from the grass blades. Chemicals are not recommended nor required to control this. This is striped smut. Kind of difficult to see, but if you're looking at those leaf blades, you'll see these really elongated black streaks. That is striped smut. It's a major cool weather disease in Kentucky bluegrass, creeping bentgrass. It is difficult to detect. It stunts the growth. The infected blades are pale with long black streaks like we see here. It causes shoes and clothing to be covered with black spores. So if you're ever rolling around and you get black spores all over you, you're probably dealing with stripe smut. The infected blades will twist and fray and turn white. Foliar symptoms appear in the summer. The management methods for this are plant-resistant varieties. Chemical control suppresses smut for short periods, but ideally you want good cultural practices. If we look at these blades right here and you look at the tips of them, they were cut with a mower blade that was dull. You can see how they're fraying. So this is a good indication that this did not have the best cultural practices, and that might have been a way that this grass caught this. This is Typhula blight, otherwise known as gray snow mold. This occurs as snow melts. These circular gray, dark brown spots appear in turf. They can range from 3 to 24 inches in diameter. There's grayish white fungal strands that can be seen on the spot margins. Most severe when snow falls on unfrozen turf and when turf is lush going into winter. The management method for this is going to be avoid fall nitrogen, use resistant turf grasses of Kentucky bluegrass, and preventative fungicide applications when conditions are favorable for this disease. Okay, so I think this is the last slide. These are some pictures, and it's going to basically, these are out of the 3A book. These are going to show you what diseases appear during what temperature periods and how to identify them, what they look like, signs and symptoms, etc. Highly recommend that you read this. It's going to tell you a lot. This is a good thing to remember. Guaranteed you're going to be asked about certain diseases. You might be shown pictures and have to identify some. But yeah, that concludes Chapter 7 of Turfgrass Pest Management, the Category 3A Manual in Michigan. I hope this is helping you. I hope it's serving you. This was a long one. I know it was. But there's a lot of information in this. So I highly recommend that you watch this a few times to cover this. I highly recommend that you look at these and study these pages in particular, these tables. It's going to help you a lot. And then we will get to Chapter 8 likely next week while I'm recovering from surgery. I'll try and make that presentation, have it up. Once I complete Chapter 8, then what I'm going to do is I'll create a practice test to go along with this. If you want to purchase it, great. If not, no worries. But, at least you'll have some sort of a guidance, so to say, to identify your weaknesses in this book, this category, and be able to go on and hopefully do awesome. I can tell you this, our National Core Practice Exam has gotten a lot of raving reviews. A lot of people that have taken it have reported that they've scored 86%. A lot of people have also said they've scored in the 90s, which for an exam that has a 70% fail rate, that's incredible. And I'm very happy and proud to say that we produce that and it's helping people. So I hope that you consider it if you haven't thought about the core practice exam. And if you're considering this, when we do release our practice exam for the Category 3A, it might be worth it just to test yourself and know where you're lacking. Other than that, hope you guys are doing well. You have a great day. Take care. God bless. And I will see you in the next one.